Let's go ahead and finish up 4.7. Um, but first, we'll take a look at this one problem from, this is from 4.6, because we're gonna turn that in today, right? Okay. So it says there's a, if you look at it in your book, it talks about television cover, and it says a television camera is on a reviewing platform 27 meters from the street on which a parade will be passing from left to right. And it says, express the distance from the camera to a particular unit in the parade as a function of the angle x. So what I've written here is express d as a function of x, because that's really what it wants. I mean, it's about a parade and a television camera and stuff like that. But the picture really focuses on this right here. So we've got this triangle, and we know what this angle is, and we want to figure out what d is. So we want to write d as a function of x. Normally we write y as a function of x, y equals. So in this case, we're going to write d as a function of x. So we want to have d equals, and then everything else on the other side. So let's just look at this triangle for just a second, and forget about the fact that this is about a parade and a camera and stuff. Take a look at where the angle is, and the fact that the street is perpendicular to this direction right here, like how far it is away. So think about the type of triangle that we have. And think about if you're working with this angle, can't we give names to these sides? So if I'm working with this angle, what name would I give this side? This would be the adjacent. And what name does this one have? This one's the hypotenuse. Don't really have a choice about that, do we? Because this is the right angle, and across from the right angle is the hypotenuse. So think for a second. If you've got the adjacent and the hypotenuse, we should know what trig function relates those. Cosine, right? So the cosine of the angle x should be equal to the adjacent, which is 27, over the hypotenuse, which is d. Good there? Okay. So that relates the variables in the problem, but is this d as a function of x? Nope, we want to have d equals, right? Right now, I don't even have the x by itself, and I've got the d in the denominator. So what we'd probably do is multiply both sides by d. And then get rid of the cosine of x. So we're going to divide by the cosine. So we could write d equals 27 over the cosine of x. And just to kind of emphasize, we could write d of x equals 27 over the cosine of x. That would work just fine. Is there another way to write it? 27 secant x. 27 secant of x. And it says in the problem, I mean, it wouldn't really make sense to turn this angle right here to make this angle get bigger than pi halves. Because as we turn to view it, as whatever's going by gets further and further away, this angle is going to get bigger and bigger and bigger. But there's kind of going to be a limit to how big that can get. It would be pi halves, or 90 degrees going this way, and then you could swing the camera the other way. So this would work as long as this was between negative pi halves and pi halves. Good? Okay. This is good review for the test. What if I asked you to graph d of x equals 27 secant of x? What if I just said, let's ignore this for just a second, what if I just said graph secant of x on this interval right here? Remember what secant looks like? Where are the asymptotes on secant? It's the reciprocal of cosine, and cosine does this. So where it hits 0, I'd have an asymptote here, and I'd have an asymptote here at negative pi halves and pi halves. And then this branch goes upward, right? So it goes like that. Now, normally, if we don't vertically stretch this, this would cross at 0, 1. So when you plug in a 0, when the angle is 0, you get 1 out of the secant. Okay? What happens when I put a 27 in front of it? 0, 27. So 0, 27. So when the angle is 0, the distance is 27. So this is the angle, and this is the distance. So let me make this a little bit smaller. If something in the parade goes by, so it's kind of marching along here, when is the distance between the whatever it is in the parade, the float in the parade, and the camera, when is it the smallest? When it's 0, isn't it? Okay, so when is this distance the smallest? Right here at 0, 27. If I go over this way toward negative pi halves, or over this way toward positive pi halves, it gets bigger and bigger and bigger. And in fact, if this parade could theoretically just continue on forever, kind of represents that infinite distance. It just goes up toward positive infinity, which is what happens when we hit that vertical asymptote. Any questions there? Make sense? Okay. Did they ask you to do this? Or even reason your way to what the graph would look like or anything like that? Did they say graph it? Okay, good. Okay, does that graph make sense? Okay, so we can use even trig functions to model some pretty interesting things. All right, maybe interesting is a stretch on this one. I'm not a big parade guy. Okay, any questions? Okay, then let's look back at 4.7. So go ahead and pull that out, and then hopefully people will trickle in here, and we'll turn 4.6 in when we're done with this. And then if we've got time, we'll take questions on 4.6 and 4.7. Remember, we'll have a review tomorrow. The review's already posted online, so you can pull that homework up, start working on those problems. I'll have a short worksheet, study worksheet for you to do tomorrow. That'll be similar to the types of things that you'll see on the test. Not trying to kill you on this one. It's the last day of the quarter. I'll make it relatively easy. If you need a good grade boost, I think if you study the stuff that we've been doing in class for 4.5, 4.6, and 4.7, you could probably improve your grade a fair amount if you work at it. Okay? All right. So yesterday we were talking about the inverse trig functions, and again, I'll make this clear. Trig functions, regular old trig functions, you put an angle in and they return a ratio. So regular trig functions take angles and give ratios. Inverse trig functions do the exact opposite. You plug in a ratio and it spits out the angle that it corresponds to. But we've got to be careful because the domain and the range are a little bit tricky on inverse functions, as we saw right here with x squared and square root of x. So we graphed sine inverse of x, and we showed that the domain is from -1 to +1, and the range, the type of angles that you get out, is from negative pi halves to pi halves. We looked at cosine inverse. The domain was the same, from -1 to +1. The range was 0 to pi. Okay, so that's a little bit different. And then we looked at tangent inverse, and tangent inverse is definitely different because of the shape. It was very easy to restrict the domain on the original function, and when we invert that function, when we find its inverse, the domain for the inverse is all real numbers. You can plug in any ratio you want into the tangent function, or the tangent inverse function. The range, the type of answers that you get out, the angles that you get out, are from negative pi halves to pi halves. So we kind of summarized this right here. We said for sine inverse, the domain is -1 to 1. The range is negative pi halves to pi halves. Okay? Or in other words, quadrants 1 and 4. For cosine, again, there's the domain, there's the range, but that would correspond to quadrant 1 or 2. And then for tangent inverse, you can plug in any ratio you want, but you're going to get an angle out between quadrant 4 and quadrant 1, between -90 and 90, or negative pi halves and pi halves, depending on what type of angles you're using. Okay? So we left off and we did these 5 problems right here. The last one we took a look at was why we don't get an answer on this one. Even if you use your calculator, you're not going to get one because any number bigger than +1 or less than -1 is not in the domain of sine inverse or cosine inverse for that matter. Okay? And we talked about how you could think about the unit circle, or you could actually draw a triangle for each one of these, okay, calling that the adjacent side in this particular case and not the hypotenuse, okay? So we're going to go ahead and do this one. Tangents can be kind of interesting because they're not ones that we have memorized on the unit circle. So let's take a look at this one and let's figure this out. This is an inverse trig function, so this is a ratio. What it's going to return is an angle, and that angle is going to be in which quadrants? 1 and 4, okay? So a lot of times this is a helpful thing to do. Think about, well, this is an inverse trig function, so that's a ratio, and then think about the type of angles you're going to get out. That's going to be really helpful in just a minute. So this is a ratio of a couple of sides. This is the ratio of the opposite side over the adjacent side, right? So let's draw a triangle where the opposite side is radical 3 and the adjacent side is 1. And we've got to make sure that, remember, with a negative fraction, you can either put it on top, out front, or on the bottom. You've got to pick. It's got to be either on the top or on the bottom. It can't just sit out front, okay? Where should it go on this one if we're going to draw this in quadrant 1 or 4? Should it be on the opposite side or should it be on the adjacent side? Should be on the adjacent? Well, if I draw a triangle in quadrant 1, the adjacent side would be positive, right? And if I draw it in quadrant 4, the adjacent side is positive. So where does it need to go? Right where it is. It needs to go on the opposite side. So am I going to draw the triangle up here in quadrant 1 or down here in quadrant 4? Down here in quadrant 4, because the adjacent side is 1 and this is negative radical 3. Remember, we made a big deal about making sure when you draw that reference triangle that you've got the sides to be the right measurement and have the correct sign in front of it. Okay? This should look familiar. Radical 3, 1, double this would be 2. This is a 30, 60, 90. How big is this angle right here? Okay, this is bigger than that one. This is the long leg, so this is going to be 60 degrees. That's the reference angle. Remember, that's the reference angle, but that's not the answer to the problem. What's the answer to the problem? Is it 300 degrees? This is going to be an angle between negative pi halves and pi halves. Is 300 degrees, or even 5 pi thirds, is that in that range? It's coterminal, okay? So if I said this is 300 degrees, it's coterminal with the right answer, but it's not between negative 90 and 90. Negative 60 is the answer. Negative 60 is the correct answer. And this is where people start to get messed up with inverse trig functions. They can draw the right picture, they can get the right size reference angle and stuff like that, but they forget that inverse trig functions have very specific ranges. So when you plug a ratio into the inverse tangent, you've got to get an angle out that's between negative pi halves and pi halves, or between negative 90 and 90. Okay? So 300 is the right idea, but it's the wrong answer, and you won't get points for that. So please don't make that mistake. Okay? Well, for most of you, about a year from now, you'll be starting a trig class, Math 1060. And this same idea applies there. Okay, so if you get it figured out now, you're going to be in better shape in the long run. So that would be negative 60 degrees, or negative pi thirds would be the answer in radians. Okay? Tangent inverse of 0. Again, this is a ratio. We're going to get out an angle that's got to be between negative 90 and 90. So if I make that a ratio, I can put it over 1, right? Opposite side, adjacent side. So this is one of those exaggerated triangles. Opposite side would be 0, adjacent side is 1. How big is that angle? 0. Okay, so the answer on this one is 0 degrees, or 0 radians. Okay? Okay, would you do this one right here, please? And would you do me a favor and do the same thing I did? Mark this down as a ratio. identify what sides these are, and then figure out what angles could be the answers, or what's the range for the answers, in other words. Let's see if I've got one. So that's a ratio. We're going to get out an angle. What's the range for the angles that we could get out? We'll do it in degrees. What is it in degrees? Negative 90 to 90. Okay? Could include those on this one. Okay? What two sides are these? Opposite and hypotenuse. So if they're both positive, if the opposite side is positive, that means I've got to be in quadrant 1. So the opposite side is radical 2 and the hypotenuse is 2. And hopefully that looks familiar. That would have to be radical 2. That makes this 45 degrees. So the answer on this one is, the nice thing about quadrant 1 is not only is our reference angle 45 degrees, our answer is 45 degrees. So we're going to answer in degrees and radians, 45 degrees or pi-fourths. Okay? Any questions? Okay. What if that had been negative? What's the answer then? Yep. It'd have to be down here because that would make the opposite side negative. That would put it in quadrant 4. Okay. What if this had been cosine inverse radical 2 over 2? What would the answer be then? Still be 45, wouldn't it? Okay, because all that does is it makes this side radical 2 and the hypotenuse 2. So this would still be 45 degrees. What if that were negative? Don't say anything out loud. I want you to think about that for just a second. What if that were negative? We're still plugging in a ratio. It's the ratio of the adjacent side over the hypotenuse. If the adjacent side is negative, since the hypotenuse can't be negative, what's the range for cosine inverse? 0 to pi, 0 to 180. So what would the answer be on that? What is it? 3 pi-fourths or 135 degrees. Okay. Does that make sense? Anybody have a question about that? It's a big deal. Okay? All right. Now we're going to use our calculator just a little bit. So grab your calculator. And so I've mentioned a couple things that we ought to be aware of in this class when we use a calculator. In a trig class, what should you always do before you punch something in? Check the mode. Okay, I've probably said that enough. I think I probably can stop mentioning that. The other thing I've mentioned is that it would really be a good idea if you tried to figure out roughly the type of answer that we're looking for before we plug it into the calculator. So we can tell if we've made a mistake or something like that. So this says arc sine of 0.78. So stop and think about this for just a second. This is an inverse sine function. This is still a ratio. How can I make it look like a ratio? It doesn't look like a ratio right now. Put it over 1. Okay? Now, again, the answer that comes out is going to be an angle between negative 90 and 90. It's positive. If you want a positive opposite side, what quadrant is the answer going to be in? It's going to be in quadrant 1, okay? And this is 0.78. That's fairly large. It's not going to be an angle that's down here. The opposite side is going to be fairly big. Okay, so we're not looking for a small angle, we're looking for a fairly large angle. Okay, not a gigantic one, but a fairly large one. And it says answer in degrees to the nearest tenth and check that to see that your answer is reasonable. Okay, so in the calculator, we're going to make sure that we're in degree mode because that's what the instructions said on this one. Okay, so I'll clear this off and I'm going to hit sine inverse 0.78. (51.26 degrees). Cosine inverse of 0.99. Cosine inverse of 0.99. Again, that's going to be the adjacent side over the hypotenuse. So that means the adjacent side is really big in comparison. So here are the options. Everybody watch, please. My guess is, and it's positive, so it's going to be in quadrant 1. Option 1, option 2, option 3. Which one of these 3 reference triangles and reference angles best represents what we think the answer might be? 1, 2, or 3? I hear a couple 3s. Anybody for something else? Anybody for the 1? 3? Okay. Logan, can you tell us why it's 3? It would be a smaller angle because the adjacent side is so big. If this side is 0.99 and the hypotenuse is 1, there's no way it's a tiny side like this. So we can take away these 2 options, and let's type this into the calculator and see what we get. I'm going to do cosine inverse 0.99, and I'm expecting a pretty small answer, 8.1 degrees.
Hey. Sorry to interrupt. Do we need stats books?
No.
The book isn't new, and we have enough for.
I'm just going to use the online one.
Oh,
So,
okay.
Yep.
Is that still part of that TICE, or is that just your choice?
No, that's just choice.
Okay.
Jeff did it that way, and I've stuck with it. So,
okay.
Yeah.
Thank you. Sorry.
Yep. Okay. What quadrant is this going to be in, first of all? Quadrant 4. 1, 2, 3. 1, 2, or 3? 1, because the opposite side's got to be so big, right? If this is negative 0.99 and the hypotenuse is 1, so if we make that a ratio, it's got to be a pretty big angle in the negative direction. So we'll do sine inverse. Whoops. Negative 0.99, negative 81.8 degrees. Negative 81.89 degrees. Well, it says round to the nearest tenth. I guess I should be rounding. So that'd be 0.3, and that'd be 0.9. Oh, let's see. I've got a typo here. That should be a tangent inverse. So that's a ratio, right? Put it over 1. This is the opposite side, and this is the adjacent side. So if I draw a triangle where the opposite side is positive 199 and the denominator is 1, it's going to be gigantic, right? It's going to be a huge positive angle. So let's see what the calculator says. Tangent inverse 199.1. Almost straight up and down, almost 90 degrees, okay? Oops, we have there 89.7. Okay. Any questions? Okay. What if a problem was written this way? What if it was written as the cosine of x is